So let's do another graphing exercise. This one has a whole bunch of things going on in it. This is exercise 13. I actually misnumbered the previous exercise. I called it 13. It should have been 12. The previous exercise was 12. This is 13. We're going to graph one full period of y equals 0.2 sine of pi x minus pi over 3 plus 0.8. And what we're going to do is we're going to apply the procedure that I've outlined on that one sheet that you guys have with the 6 steps that gives us a step-by-step procedure to graph any function with all, trig function with all this stuff going on. So to get going, we want to identify these coefficients, right? We want to realize that the a value here is 0.2. The b value, the b coefficient is pi. C is pi over 3. And d is 0.8. So we have a b, a c, and a d to deal with here. And one way to approach this is to draw a preliminary graph first. And that's what I'm going to do here. My preliminary function is y equals 0.2 sine of pi x. So I have the same a, the same b, and we'll deal with c and d in a later step. So for this preliminary, the amplitude is equal to 0.2. That's the absolute value of a here. Here a is positive. And the period is 2 pi over b. I'll use our 2 pi over b formula. So that's 2 pi over pi. So the period is exactly 2 units. Notice that pi has dropped out, so I won't be labeling pi on my x-axis. And to get the important points, I want to take the period and divide by 4. So I'm going to take 2 and divide by 4 to get 2/4 or 1/2. Now let's go ahead and start graphing this preliminary function, right? The y equals 0.2 sine pi x. Since the amplitude is 0.2, I want 0.2 and negative 0.2 to be labeled on my y-axis. On my x-axis, since the period cut into 4 pieces gives me a half, I want to label every 1/2 unit. So I'm going to go 1/2. Another half is 1. Another half is 1.5. Another half is 2. And so that's my x-axis labeling. And we're graphing a sine wave here with, now the preliminary graph has no horizontal shift or vertical shift, so we start sine at 0. We rise up to a max point, which is going to be at 0.2 units above the first important x point. Then we come back down to 0 to the x-axis at 1. And then at 1.5, we dip below to our min point, which is negative 0.2. And then we rise back up to 0 at 2. And there's one period of the preliminary graph. So that's a picture of y equals 0.2 sine of pi x. Now to work on the function we really want, we got to incorporate c and d. So we need to think about now the vertical shift and the phase shift. The vertical shift is determined by the D coefficient. That is 0.8 upwards. We're going to shift our graph upwards by a certain amount. And our phase shift if you use that formula, C over B, you can plug in the C value of pi over 3 divided by the B value of pi. Pi over 3 divided by pi is 1/3, and that's a shift to the right. Now, if you ever get confused, because there's some trickiness with plus and minus signs here about whether we're shifting to the right or the left, you always can fall back on the original equation. And that's what I do. I always rely on the sign in the original formula to help me see whether I'm shifting to the right or to the left. If there's a minus sign inside parentheses here, we shift to the right. That horizontal shift, that phase shift, is always kind of opposite to the sign. If that were a plus sign, we'd have to shift to the left. So we know we're shifting to the right. And now I'm going to have to figure out some important values to plot. So to do that, what I'm going to do is I'm going to work from my preliminary graph to get new x values to use. And so I'm actually going to take 0, 1/2, 1, 1.5, and 2. 0, 1/2, 1, 1.5, and 2. And I'm going to add the phase shift onto them. Now, we want to go to the right, so I have to add 1/3. Make sure this takes you in the right direction. I know there's a minus sign in the formula, but because we have to shift to the right, here with our x values, we have to add 1/3 onto each one. And that's going to give me the important points, the important x values for one period of our final graph. 0 plus 1/3 is 1/3. 1/2 plus 1/3 is 3/6 plus 2/6 is 5/6. 1 plus 1/3 is 1 1/3, or 4/3, and just for the record, I want to make sure you realize that's 8/6, right? 1.5 plus 1/3 is 3/2 plus 1/3, which is going to be 9/6 plus 2/6, or 11/6. That's the same as 1 5/6. And 2 1/3 is 7/3, which is the same thing as 14/6. So we got a bunch of different ways of writing each one of these fractional values. Now I'm going to try to, I wanted to kind of get my two graphs to line up a little bit here. So notice I've already set up a x-axis and a y-axis. I'm going way above the x-axis because I know I'm doing this vertical shift upward. And I'm going to try to match the scale here. So I'm going to put a 0.2, but we got to shift upward, so next comes 0.4, 0.6, 0.8. Let's try to keep those guys separate. And after 0.8, 1.0, 1.2 on my y-axis. And for my x-axis now, I'm going to label these important values 1/3, 5, 6, 8, 6. Now, it's kind of easier to think in terms of 6 here. 1/3 is the same as 2/6. And what I'll do is I'll think of each square as going across as a 6. So 1/6, 2/6, That's where a third is going to be. 3, 6, 4, 6, 5, 6 is here. 6, 6 would be next. That's one whole. I don't need it, but I'm just marking that here. 7, 6, 8, 6. There's my 8, 6 or 1 1/3. 9, 10, 11, 6. My 1 5, 6. And 1 6, 6, by the way, that's where 2 is, right? So let's see, that's 11, 12, 13, here's 14, 6, or actually 2 1/3. So notice between each one of the important values from here to here, from here to here, from the way I set this up, there are 3 squares, so they're all equally spaced. And those are going to be the important x values I need for drawing my graph now. So I'm going to take my preliminary graph and I'm going to shift it to the right and shift it up. I'm going to take this 0, 0 point, and on my final graph I'm going to shift it over to 1/3, 1/3 to the right, and then shift it up to 0.8. So that original 0, 0 point ends up way up here. And let's see, next, now I'm drawing a graph of sine, so I know I'm going to rise up 0.2 units. So at 5, 6, I'm going to be at 1.0, I'm going to be 0.2 units higher at that max point. Then at 1 1/3, I'm back to 0.8. At 1 5, 6, the next important point, I dip down to 0.6, which is 0.2 below 0.8. And then at 2 1/3, I'm back to right here, 1/8, or 0.8. Okay, so there's my graph. My final graph of, I want to recopy the equation here, y equals 0.2 sine of pi x minus pi over 3 plus 0.8. Notice there are no pi's labeled on the x-axis, even though there are pi's in the formula. And just a couple other things. We're done with our graph, but I just want to point out a couple qualities here, a couple aspects of things. That horizontal line through 0.8, which cuts right through the center of our graph, sort of, its equation is y equals 0.8. We call that the midline. And the largest y value that we hit, so at this point here, our y value is 1.0. We say the maximum value, or max value, of this function is 1.0. And notice the lowest point here has y coordinate 0.6. So the min value of this function is the y coordinate at that lowest point is 0.6. So sometimes in the homework they ask you for the midline, the max value, and the min value. Okay, and there we got our graph of y equals 0.2 sine pi x minus pi over 3 plus 0.8.